Hi friends, today let's see how modern embedded devices such as Raspberry Pi and ESP32s can seamlessly exchange data using popular MQTT protocol. There are enough reasons to learn MQTT implementation, and this video can give you a head start to apply this technique in your next IoT or robotics project. So here is our demo setup with a Raspberry Pi and two ESP32 microcontrollers. The client programs running in these devices are going to publish and subscribe sample information on MQTT network using the three topics as shown. The client programs are written in a fail-proof manner. In case Wi-Fi or MQTT broker is down, clients can auto-connect to them on availability without any manual intervention and ensure flow of information. Let's see the demo and code for this implementation. On my computer screen, you can see that I have taken remote of my Raspberry Pi, and on this camera screen, you can see the two ESP32 microcontrollers. ESP32 is an amazing piece of hardware. It has built-in Wi-Fi and many other advanced features at a very low cost. These are the client Python scripts placed in download folder. I have already installed MQTT on my Raspberry Pi using these commands. We can check the status of broker. It is showing active. Now let's run our Python scripts. The first script successfully connected to the broker and waiting for data. Now when I run the other script, which publishes sample data, we can see that data started appearing on the first script. The code for this script is simple and less than 50 lines. We simply create an MQTT object and it connects MQTT broker running on the same machine. If your broker is running on any other Linux machine, just change this IP address here. Callback functions are added to handle the incoming data on these three topics. Inside the callback functions, I am just printing the received data on terminal. You can place your data handling logic here. The other script is used only for publishing sample data. It also connects to the broker and starts publishing a counter value every 2 seconds on this topic. So if I stop this script, you can see that the other script also stopped receiving the broadcast message. Now let's power up one ESP through laptop's USB port so that we can see its code activity on serial monitor. After booting, it first connected to Wi-Fi, obtained its IP address, and then established connection with MQTT broker. Now we can see that our script on Raspberry Pi started receiving data from this ESP. The data is just a fixed value confirming that things are working. This part of the system is now working. Let's power up the other ESP using a power bank. It also connects itself to Wi-Fi and broker and starts publishing data, which can be seen here. This part of the system is also working now. Now let's turn on our broadcast script. Notice that this broadcast message is received by Raspberry Pi and ESP simultaneously. The complete setup is now working. Stopping the broker would result in disconnection of all the clients. The moment broker is stopped, you can see both the client scripts and ESP lost connection, but they are still running and trying to reconnect. So when the broker is again up, the clients start connecting to it automatically without any manual intervention, and the data flow is resumed as expected. If any of the device loses its power or gets disconnected temporarily, when it is powered back, it resumes its role as programmed. Both the ESPs run identical code with a little difference. Let me show you the difference. While connecting to the MQTT broker, they should connect with a unique name. They can receive the same broadcast, but they can be programmed to process this information differently. They publish to different topics. Rest of the code is identical. With these differences in mind, you can create a swarm of these devices, all reporting their individual sensor data to a central location and getting control direction from a master device. The links for source code and written guide for this project are available in the description below. Also, check out this website for more projects on robotics and IoT. I hope you enjoyed this video. Stay tuned for more such videos and thanks for watching.